Good morning, everyone. Welcome to my presentation about Buildpacks. I'm happy that so many turned up after last night, I guess. Um, so we are here to talk about Buildpacks, and my initial question would be like, who knows already about Buildpacks? A few of you. So I would actually even ask a more important question: who is writing their own Docker files? Hands up. Okay. So my goal of the presentation is actually that I can, well, I don't want to say convert or convince you actually like to use Buildpack instead of Docker files, but I want to show you actually that if you use this kind of technology, you can remove your cognitive load actually in the project. You don't need to know about infrastructure and all those kind of things, and it's so much easier actually like to build containers for your application in the cloud. So that's why I'm going to introduce like the Buildpacks. I will show you like one or two examples like you might face in the enterprise environment, because you know enterprise is always tricky. It's always like certificates, proxies, and all these like things. And of course, you need to find ways around this. And you will hopefully in the end like get an idea what Buildpacks is, and you would say like, at least I need to try it out, or I got convinced that actually like you should use it. By the way, another question, who is using Spring Boot in here? Well, you would have the tool already actually like inside your Gradle or Maven plugin actually like to use Buildpacks to create containers, right? But anyhow, we'll get there afterwards. So who is me? Who am I? I'm Patrick actually. You might hear that from my accent. I'm from Switzerland. I'm actually around working with teams to like deliver better quality of software faster, usually. That means like even though I'm a Spring developer since many years, like over a decade, I think actually like I love to create like solutions with humans, and like Spring or any other Java technology is just a tool for me to achieve the goal, actually like to satisfy a business need, right? I'm also doing, besides that, developing and coaching and teaching and reviews and so on. I'm like lecturing at the University of Applied Sciences in Zurich, and also I'm part of the Swiss software development community as well. But that's not so important. That should just give you a little bit like of background who I am, and that you understand like why I maybe fall in love with Buildpacks a few years ago. So the goal actually of the presentation, I want just look to highlight a few things, is actually like what are containers really, right? I mean, you probably know that, but it just sets the base. And then actually we dive directly into the Buildpacks, and then we are comparing the Buildpacks to Docker files. And you will actually realize how simpler things actually get. And then we are talking about some other topics, as I said, some enterprise features, maybe some security features, also maybe some advanced Java features you might need as well. And in the end, I will show you also some examples of like how when you run a Buildpack, how actually like the console log look like, that you better understand like how things fall in place. So what are containers actually? You probably know that like OCI compatible containers, like Docker containers, they are based on layers. And it's kind of, or they use underneath like Linux technology to limit resources and use this as a way of like isolation. So kind of like that we virtualize an application and so on, right? And for us, important is to know that basically like the kernel is always part from the host system, and then we have a base image that might be like an Ubuntu, a Debian distribution, and then we add layers on top where we install like the JVM, where we add our application, we add some metadata, we define how the application gets started and so on, right? So this is just like the layering of all these container images. Now that's a thing, because we will see that also when we do afterwards or have a look at the container at the Buildpacks, they will still create this kind of layers. So what are Cloud Native Buildpacks? Buildpacks is actually a standard at the Cloud Native Foundation, and Buildpacks.io defines that. We will just see later they have some artifacts actually defined, and there is actually even I would say like a default implementation for that. So if you think of the Buildpacks, actually, Buildpacks were originated at Heroku like long time ago. Think of like 2011, 2012, it's already there, right? They used it actually like if you clone a repository, they created for you the container and they were deploying the application for yourself. Then a little bit later actually, around 14-ish, there was like Cloud Foundry doing the same, and there was a second version of Heroku actually like with this Buildpack approach. And then later, around 2018 and 19, Pivotal and Heroku joined, and Pivotal now is actually part of VMware. They joined forces, they defined a standard, and they published it as like Buildpacks at the Cloud Native Foundation, and also under this buildpacks.io. Right? That's actually like the idea. You would even say like Docker files are around the same time actually. You could say like Docker files was also around like 11 or 12, and then actually like around 18 they did something like multi-stage Docker files later, right? So they basically kind of followed the same timeline. They were just like, yeah, besides this movement of Buildpacks. The great advantage actually like of Buildpacks is you do not need Docker files at all. You don't need to do it. And you will realize later, and I'm going to show you, that there is so many ways how you can do things wrong if you write your own Docker files. And that's something we are going to discuss in a few minutes. So Paketo is like an implementation of these Buildpack standards. It's a CLI tool you can actually use to create those containers. And what I like about Paketo is it's a huge ecosystem, so you can actually use Paketo to create containers for many different technologies. And it doesn't matter like if you're using Java or if you're using Go or PHP or whatever, Buildpacks are creating for you the container. So you don't actually need to know how in these technologies, like how you create your own Docker file. Or even better, you don't need to copy it from the internet. Because, as I said before, there are so many things wrong. But we get into this. So Buildpacks actually like simplify the way how we are creating containers in general. They are also great because you can imagine if you're working like in a company with many teams, probably every team has another way how to create Docker files. And that's maybe also not a good idea. So you could basically like make this consistent across teams if all of them use like Buildpacks as well. Then also like there are features built in regarding security. So for example, there are SBOM files created during the creation of the containers, images, right? And they are attached into the container. So you can always like see like what's in there, what kind of packages for the Linux distributions are used, what kind of jar dependencies you have, and so on. And think of like JavaScript and Python exactly the same. Then actually also Buildpacks are maintained by the community. So if there is, for example, a vulnerability inside the Ubuntu distribution, if Canonical is getting like a fix for Ubuntu, then it will show up here immediately. So that means like a CVE pops up 2-3 days later when it gets fixed actually, you immediately have it actually like in your container images. So you don't actually need to care about like upgrading those things because the community will actually take care of that. Or think of like upgrading to a newer version of Java. The Buildpacks will do that automatically for you, or like some contributors actually like who are upgrading the dependencies for the Buildpacks, right? Another thing which is actually great, and we always like go more towards that direction, is creating reproducible builds. And I'm talking here about binary reproducible builds. And Buildpacks actually can do that for you as well. So if you're building your application the same way, you will get the same result at the end, binary compatible. So that's, I think it's also like very important so that you exactly know what was deployed in production and you can rebuild it again and you compare if it really was that thing. And then of course as well, it fits very well into a DevOps setup because actually I think it should like be part of your pipelines anyway. Great. So actually like the ecosystem for Buildpacks is also huge. Think of like cloud platforms, like for example, you have the Google Cloud, in Azure Cloud, you have Heroku, Fly.io, and so on and so forth. They are actually also like supporting Buildpacks. There are CI/CD tools actually, like where you have plugins to build Buildpacks, of course. And then you have like, for example, Maven or Gradle, or maybe the Pack CLI. You can even run in your local setup if you want to. So that means basically like all these areas are actually covered. Then actually you have in the middle like the Buildpack standards, you create the images, and then you push it actually to an OCI compatible registry. And imagine if you go, for example, to Docker Hub, you will actually see that, I mean, you would see with the Docker files, the Docker file, the layers which were created. Now you see actually like when you created with Buildpacks on which step the layer was created actually. So you see also some metadata from the build process, and you know like which layer was when created and so on. So container registry support that as well. Okay, so this slide just should show you some products. I'm sure you're familiar with them. So maybe you just go and look up the documentation, how you could use it in this environment. And there are many, many more. So imagine actually you have your source code and you want to have a production-ready container. So that means like you do not want to change anything in your container when you move to production. It should be just like the way, the optimized way. If you run it like maybe in a testing environment, you might provide some parameters where you can like enable certain features you need for testing purposes. That's okay, but it's always like made for production first, right? And with the Buildpacks, you just basically can automate the way how containers are created, of course. So the artifacts which are provided by the standardization body, this Buildpacks.io, is actually the pack CLI. They have a specification and they have a lifecycle library. So the lifecycle library is actually something which defines the process, how these layers are created and all the steps behind. And we will get into that also a little bit later, and I will show you that you see like how the lifecycle actually looks like when a container is created. Right? And of course, they have plenty of examples as well. So just look it up. Actually, they have also good documentation for these kind of things. So why should you actually use Buildpacks instead of Docker files? It's just because we have some limitations actually like in the Docker file. Think of this, and please don't take a picture of that because it should not go to production at all, right? There's so many flaws in here. And maybe some of you have an idea what kind of flaws we have in here. Does someone has an idea what's wrong? Yes? I could write to file system. Why? It runs with the root user, for example, right? So we have here a privileged user. Then I actually like get the container from OpenJDK, which is outdated. Nobody tells you during the creation that it's outdated and you should not use it anymore. So actually like they changed the name, they moved it, and you get like the latest vulnerable, I mean the latest means like the very old vulnerable version actually in here. If this is a Spring Boot application, don't deploy a fat jar ever, because Spring Boot apps start faster if you deploy it in a exploded version, right? So if you unpack the fat jar basically, the startup of your Spring Boot app is way faster. Then actually another question would be like, what are the right parameters for Java actually like to start the JVM? Is this the right one? I mean, it's the simplest one. It's using the default parameters. I'm not sure if that is great, right? And so on and so forth. So you see actually like this kind of thing has many, many flaws. And on my slides actually below, I linked a very nice blog post from SNCC where they are showing when you're building a node container, and the same thing actually also applies to Java, what you can actually do wrong. And Buildpacks are actually like solving all these problems. So really like have a look at the blog post. I like it a lot, and they're telling you like what you can do wrong and how you should do it better. And I'm just telling you, Buildpacks are doing it the right way. So actually like when I'm using Buildpacks with the CLI, I have some commands I can execute, obviously. And I'm not using now the Maven plugin, I'm just showing you some commands actually like from the command line. And you can actually even choose different kind of Buildpacks or Buildpacks builder, depending on the ecosystem. So if you're deploying, for example, to the Google Cloud, the Google Cloud has its own one. They have their own way how to do things. If you take the regular one, you would get an Ubuntu Chami, or you can even like switch to an Ubuntu Noble as a base image actually like for your container. And actually like I like the Paketo Buildpacks a lot because like they provide a lot of tools actually like for the Java ecosystem. The Google one is not as far as good as actually like Paketo is. And just on the side, Spring Boot is actually using Paketo behind the scenes. So if we look actually at the container starting, and I know it's slightly small here on the slide, starting actually like in a container, there is a thing you will actually realize. Your Spring Boot application has quite a lot of output here, and I just wanted to highlight everything which is above here. So, oh, sorry about that. I just really wanted to highlight this. This is basically like everything created by the Buildpacks. So think of like there is a statement which says, I'm using a memory calculator to calculate the resources for the JVM. So everything you actually like provide to the pod, for example, it's used in the calculator as a parameter, and they calculate like the best memory configuration for that. It's quite stable. I know the tool already like for 12 years. I never had issues with these kind of things actually like for our application we put into production. Another thing you actually realize here is actually like that certificates are added actually to the CA certs of Java automatically. So they copy from the container the CA certs into the Java distribution during startup. And you could actually provide your own ones, like from your internal certificate authority. Another thing you might realize here is the Spring Cloud bindings, and that's actually like what enables on the actuator the liveness and the readiness probes automatically. If you run it locally, you won't get those, but if you run in Kubernetes, this tool actually like is doing it for you. And then actually like you have like many other Java options provided. Parts of them are actually like the ones we calculated before with the memory calculator, but there are other things like, for example, exit out of memory error, for example, or you see also like some memory tracking, you see like the enabling of the cloud bindings, and so on and so forth, right? So you start Java not just with Java minus jar, so you do like way more than that. And fun fact on the side, it's not using the root user. It's using the CMB user, which means just like Cloud Native Buildpacks user, which is not a privileged user at all. So we are doing many things here the right way. Great. So think of that now, and think of like your Docker files, how you're going to add like to the CA certs file actually like your custom CA. And you would actually like use the key tool to add it like this, right? Yes. And well, I mean, you can do it, but there are so many simpler ways. If you're doing that, for example, like with Buildpacks, you basically just mount in the command below here, you mount basically a directory I created here with the structure where I have my certificate like provided, and it just automatically during the build of the container image, it adds it into the directory so it can be applied during startup to the CA certs to the Java environment. Right? It makes things so much easier. You can also use like the certificates for build time when you need to like call out to download certain things like from a repository, or you can actually also define it for runtime. So you can actually decide, right? And just to show you the example below, we had like 146 before. Now this one shows like the example with 147 actually like added to the container. So it's the one above I did as an example. Okay, and I was not faking it. I was like really doing it. So believe me. Great. So imagine now you do the same for other technologies like Go, Python, PHP, whatever, it doesn't matter. It's exactly the same. You don't need to do it in a specific way. You just use the Buildpacks, you add the certificates, and the Buildpacks will take care of it. So it really like simplifies how you're going to create your containers. So if you're now looking at the architecture of Buildpacks, actually like you will have like a few things in there. You will actually have something like a build image. So that's like a container which is used basically like to create then the final container. You have a run image, which is actually like the base for your container where the application will be in. And the Buildpacks itself, there are just like different tools which are kind of manipulating the layers. So like, for example, one Buildpack might install the JDK. Another Buildpack actually like might run the Maven build. Another Buildpack might add the CA certificate. Another one will actually like install and run SIFT for the SBOM files and so on. So think of Buildpacks as like a chain of tools which are executed one after another, and every Buildpack is actually manipulating the final result of the container, right? And if you now do this in a certain order, you have this kind of life cycle. And we will see in the life cycle there will be some phases actually like which are special, because you have to find out if the build pack needs to run or not, for example. So you have kind of a detect phase. And then you have the build phase, of course. And the builder, it's everything above together. So it's basically like one huge container which contains everything. And when I say it's like huge, it's like 1.5, 2 gigabytes big usually. So it's basically like the whole summary of all the things above. So as I said before, a build pack actually like has like certain steps. And the build pack actually is described by a TOML file where you provide metadata. So that means like you are defining like version numbers of that build pack, but you also define on what you depend on. So think of the Java build pack. The Java build pack actually like will depend on the installation of Java. And for example, if you're a Spring Boot user, it will also reference actually like the Spring Boot build pack, which will do some things, right? So the TOML file contains this metadata. And then in the build pack itself, we have like the detection phase, which actually checks like if it needs to run or not, right? And in the build phase, basically like the change of the layer basically happens. Great. So here it's just a little bit more specific. Think of actually like if you are using build packs for a Java application, it will find like jar files or Java files inside your sources. So the Java build pack needs to run, right? If you think of Node, if there is an index.js or a package.json, then the build pack will run. That's kind of the detect phase. The detect scripts are actually like executables. You can do it as, for example, binaries, or you can actually do it even as shell scripts if you want. And I'm not like a person writing Go, but in this ecosystem, actually, people like to use Go. There are even frameworks which help you with all these things to simplify that. So that would be like a Go executable, the detect and the build thing. But you can also create the bash script if you like, right? And if you have the build phase, as I said before, you might install the JDK, you might compile the sources, you might even like add the launch commands if you want, right? So this is kind of like what the build pack actually does with these two steps. Now in the life cycle, we have like the analyze, the detect, the restore, the build, and the export phase, where the analyze part actually like checks the metadata from even previous builds. So that means like if in the analyze phase, they detect that like some data is already cached, some layers are already cached, we can actually reuse it, right? So this kind of thing actually happens at the beginning. Then we get into the detect phase, where we check which build packs need to be applied. And then actually like the restore phase will restore now the cached versions, so we can reuse it afterwards. And the build phase actually like just creates the layers which are needed to be created because something has changed. So build packs are even great because like they relink basically like the layers. And that means like you can speed up your build process with things you have done before. Right? And only when it's changed, that layer needs to change. And this is different from your Docker file, where you have like in a command like run or copy, where you have a change, and you need to do all the step afterwards, right? To do like the container. So Docker files need to like create all the other layers after you have a change in your Docker file. And the build packs basically like just change one layer, and they can relink all the others. So you're way faster. The export phase in the end will create for you the container image, finally, right? So that's another thing. Great. So this is basically like the build picture, the big picture. A builder consists usually like of multiple build packs, and we have kind of a stack. Stack is like a deprecated term, but it's still used in Paketo, but it should have been like removed like by last year, but they didn't do it yet. But stack is kind of like the boundary for like a run and a build image. But they just removed the term of the stack, so actually like these days, or like with the new specification, the run image and the build image are still there. So don't get surprised if sometimes they talk about the stack, which is basically the run and the build image, or if they just refer directly to those two images. Right. Now the question is actually like when you use build packs, you have kind of a standardized process, but you need to customize it. You need to customize it because of many reasons in the enterprise. So that means like you might want to change, for example, the JDK because you need to do that. Or maybe you need to use a specific run image. So think of like you're a Kubernetes user, like an OpenShift user, and they force you in a way to use UB9 as a base image for the container environment. So even like Paketo has like run images based on UB9, and you could just use that. Or you go like with Ubuntu or something else actually. In enterprise, you always have issues with certificates, right? If you have like an internal CA, so you need to provide the certificates too, and so on. So there are like many things. Also like things like proxies and stuff like that. And you need to configure, or you can configure those things like via environment variables during the build and during runtime. There is actually like a very nice feature I like a lot, is actually like the rebase part. So think of that you have built your container and you would just want to exchange the run image below. You can do that with that single command. Just switch the base, the run image on the bottom, and say, now I have the current version of my run image. Right? I mean, you could say, my pipeline runs fast enough, that's great, but if you get a container from a vendor, for example, and you have serious vulnerabilities, you as an operator of this platform, you could say just like, I changed the run image and I will now use the newest version of your Linux distribution. I mean, that's great. You still need to test, right? Because it's not guaranteed that it will work always 100%, but that's another topic. You might make it work for your setting. And there is actually even a catalog with quite a lot of build packs in there. Have a look. There are also many vendors, like as I said before, Paketo, Heroku, and many, many more. I don't know how many hundreds are in there, right? So Paketo is actually like the thing I use a lot because I'm using Spring. And Paketo has by default like 3 different distributions. So they have kind of a middle version, so that means like the run image is kind of like the middle version, and there is a very tiny one, which is usually used for executables, but actually Spring Boot works with that too, so that's actually like the tiny one is the default now in Spring Boot 3.4, and you have like the full one, which has like lots of things, like a full-blown operating system with all the dependencies. You can choose like what kind of distribution you want to use in Paketo. Of course, you have like as we have seen even in the picture before, like different platforms, programming languages supported and so on. And you have like quite a lot of tools, as we saw as well for the certificates, for the SBOM generation, for annotations and labels, additional ones. And as you can see also, like I think Spring Boot uses that feature since like last November. You can even like create containers with ARM64. That means like it runs on your Mac. Right? You don't need an Intel Mac, so you get actually a container on your Mac actually like with ARM64 distribution in there, or you might even have this Red Hat UBI distribution in the container as a run image. So I mean, that means like we can really like choose a lot. Just as an example actually like how things with the SBOM files are attached, there is a command basically like to extract from a container image like all the SBOM information which was generated during the build. And as you can see here, we have like hashes, we have like our Maven dependencies in there. You can think of like what is the dependencies for the operating system and many other things. So there are like several files in there you could actually use, right? Just as an idea, because that's something we anyway have to provide soon because of some EU regulations, providing SBOM files when we deliver something, and it's just like built in. So if you do it the right way, you just gain from that. Now I'm showing you an example as well. For example, if you need to add an agent to your container because of reasons, you can actually like specify that an agent gets added automatically. So in the Java build pack, there is, for example, an agent like the Datadog one. And if you specify with an environment variable, saying here, pack build -e, I'm enabling that agent so that the agent gets installed. And when you run the application, of course, the agent will be passed to the java -char command, of course. And then actually like you might need to configure it, and you would use on your Docker run as well an environment variable to specify like where is the site, where is my API key, and so on and so forth. So that means like you can have environment variables provided during runtime. So during build and during runtime, you can do things like that. So that's quite handy actually, and makes things a lot simpler. So if you now dive even deeper into the Java part, there are like environment variables, and I will show you them afterwards. For example, you specify a Java version, because you can be very explicit. You can actually like specify the builders and the build packs you want to have, as you see in the example here as well. So I'm using the Adoptium one, and then I specify additionally, and that's necessary actually, the Java one to inherit all the other Java 1 features. And if I just would specify Adoptium, there is nothing like, for example, CA certificates, no SIFT for SBOM, no Spring Boot build packs running. So basically, like, I need the Java one to get like all the additional features, and I'm basically overriding the one which installs the Java distribution, right? There are in the build packs like features, for example, for Spring Boot, like the AOT part. So like enabling AOT from Spring Boot, so that means ahead of time processing, that you don't need to do component scanning and like reflection stuff, so many things actually like were built into code. You can do that here. Also app CDS, which is kind of like a caching during the startup, the cloud bindings I told you before, and the memory calculator. There is another feature which is called like JLink. Who of you knows what JLink is? Hands up. You can create a custom JVM, right? You can shrink your container image by just like providing the feature you need from Java, which is actually awesome. You make your container smaller, means like it gets distributed faster over the network, and so on. And also, for example, Cloud Native image support would be also part of the build packs automatically. So you really can choose a lot. Now let's have a look actually like how it looks like. And I just wanted to to show you actually like what I executed, because I know the presentation is like really tight of time, so I could not run everything. So I was running the commands before and then just going to show you how it looks like, right? So you get an idea, and we don't have to wait. So there is this command called package or pack builder suggest, where you can see some examples how you could actually like select the builder. And you can see here there is like Google one. There is a builder for Heroku. They're like the Paketo Buildpacks in different flavors. So they will tell you this, but there might be other builders as well. I will show you some examples like afterwards. If I run that with the Google one, you will actually realize that the Google one actually like selects 4 out of 5 build packs. And we are having the phase analyzing, detecting, restoring, building, and of course exporting at the end. And you can exactly see like what happens here, and it would restore things like it does here, because I have been running those actually before already. So I can actually gain from that. And this was just like the selecting part was just executing the detect binaries. Great. And then actually like you see during the build phase that it's going to build my Java application, that it's using even Maven to basically like build, because we have a POM file in there, right? And then at the end it actually like creates the layers and exports it as a container. So if you're using Paketo, and I'm just showing the one with Jammy, it's different because like Paketo has like 26 build packs, and we get selected like 10 out of them. And have a look at those. I mean, there is Apache, Tommy EE, Liberty. Probably I don't need that for a Spring Boot application, but they're still there. Doesn't mean actually like that there will be done something, but there could be done something. There might be additional checks afterwards. But you will see that if you do this with Spring Boot, they don't even show up here. But we have here like certificates, Java installation, the SBOM stuff, the Maven build, right? And then the Spring Boot build pack. And as you can see as well here, and you see it even better, they even print out the default parameters you could actually override with environment variables. And you will see actually like that it's going to install like a Java version, but now it's actually cached in this way. But you would see actually like it's downloading it basically, and it's installing it actually like in the container. And of course, during building, you need a JDK. During running, you just need a GRE. So you actually like will get both of them. Right? So that's basically like the big difference. And then actually like when the Spring Boot one actually is running, you will see here first for the executable jar, it checks like the manifest for the main class. And then for the Spring Boot one, it adds like some Spring Boot parameters as well before it's actually going to export everything. Okay, so maybe I just show you like the last example before I dive into the rest of my slides. I'm using this one here. Yes. So I'm using the Spring Boot example. So I just do here something like mvn spring boot :build minus image, and I just use the build packs actually like from Spring Boot. So the Maven plugin is going to run actually like Paketo stuff. So what they have done is actually like in the Maven plugin, they have implemented the lifecycle plugin, so the different steps, and they will execute them behind the scenes. So this part is just compiling, and you can imagine actually like we do a Java minus jar, so the build packs, when you do it with the Maven or the Gradle plugin, it does not need to build the application anymore. So no need for a Maven build pack, for example, as well. What is quite interesting is actually like the thing that you see here, that it's going to download basically like the builder, and then also like the run image from Jammy, right? So that means like the Ubuntu distribution which runs everything. And then actually we are going to select now 6 of 26. So before, when I used the CLI, it was like 10 of 26. Now it's 6 of 26. So we don't need the Maven one. We don't need the Liberty, the Tommy EE, the Tomcat version. So we just run it as like Java minus jar, exploded, of course. Okay, so it's like the selecting part. And this is something you will see here as well. And then it's basically going to calculate and install the things with the parameters and so on and so forth. And in the end, it's going to create also the container. So basically, like the Maven or the Gradle plugin from Spring Boot do exactly the same behind the scenes. Right, great. So let's jump to the rest of the presentation. I will actually like show you some more examples and also some challenges I had in the past. And one thing actually like I had an issue with was fonts. Well, actually, like in enterprise, you wouldn't have an issue like that you don't have emoji fonts in the container. I had some in my pet project, right? But you might have the issue that you need a corporate font installed. And the problem actually is there is no emoji font inside the container. When I execute the application locally, it's fine. If I do it on Windows, Linux, and so on, Mac, then it uses always like the one from the operating system as a replacement, but in the container is nothing. And I learned it really like the hard way. So what I did here is, I'm basically patching the run image, as you can see here, right? And install it with apt-get, like in a Docker file, and use this now as my base image, right? So this is actually like how you should do this for fonts, because you need like root user to install additional software. Well, you might have other ideas like what you want to like install. For example, you want maybe to do additional JVM tuning. You might want to have a specific version of the JDK, which is maybe not even like in the build packs anymore, or maybe you even built your own JDK, I don't know. You might inject configuration for your application, but also maybe for logging. Maybe you need some other things regarding checking for license compliance, and so on. And actually, like you can even create your own build pack in a very easy way. Basically, I show you at the end a link to the GitHub repo I have. So I have some examples there too. So Spring Boot actually allows me, even like in the POM file, for example, to specify a specific builder. And I have done my own one because I said I want to have like a newer version of Linux, or even a specific one with additional things. So I created my own builder actually. So that means I have like my base image for the run and the build image created on my own. That's very possible. And you just provide this as an argument to the Maven plugin. Or like selecting actually like the build packs. You can also do it in a POM file in a very easy way. And just I show you here as well like which other Java distributions are out there and you could actually use. And that's just a way like how you could like select one of those. If you think of JLink actually, which you always should do, I think, is actually like you provide a parameter saying, I enable JLink, and it will try to find out by default which modules will be used. And if you're smart, you can do it on your own and can even specify the parameters additionally. And you just like say, these are the modules I want to have in my custom JVM, right? And then also like no man pages, no debug stuff, no header files, and also the compression algorithm you can choose too. Okay. If you think of like AOT from Spring Boot, so ahead of time compilation, but not for Graal native images yet, it's more like no component scanning needed anymore, the conditionals are evaluated already, and so on. You can actually do that also by specifying a parameter. and also like having an initial execution phase, because like the Maven plugin needs to process your Spring Boot application during the build time first, and then it needs to add a flag so that the feature is enabled during startup. And app CDS basically means like you are starting your app, there is a training run in the build pack, which will dump everything, all the classes loaded to one single file, and then the build pack makes sure that if you start a container, that thing gets restored. So it will use actually like the archive from app CDS to start your application, and your application will be way faster. And you don't need to script it. It's just like a parameter you add. So this stuff is way more simpler. Great. So it's very important that you know like how to use those things, and also that you're using the right build packs, of course. I mean, I found out for myself actually like that the Paketo ones are just like good enough, and it's also very easy to contribute if you find something. And I also have done in the past some upgrades of Java versions of certain distributions and other things, so people are super friendly, and usually like the community is accepting those things very fast. There is basically also like a trick, and I haven't mentioned it before. I'll just explain you this. Spring Boot actually like is kind of a release train of like certain releases. And if you use the build packs by default from Spring Boot, they are using specific versions of the builders and the build packs. So they're like kind of pinned, right? If there is a new Java version out there, a feature because they just released like a Java distribution you want to upgrade to, and you have to wait actually like with Spring Boot for the next minor or micro release actually by the end of the month, you could also say like, I'm using the latest version here, and this is basically just a tag from a Docker container, and you can say like, I always want the latest, not the one actually like Spring Boot has in its release train. Right? So you can actually like start experimenting with features which are coming maybe like in a few weeks. So choosing the right build packs is very important. And of course, actually, like if you are creating a pipeline, you're probably also doing already some security scanning. And there is also even some stuff built in, as we have seen, like with SBOM. So that means also like tools running inside your Kubernetes distribution can actually like easily detect those metadata, and will actually like show you what's running actually like in the cluster, because you just provide actually like all these informations. Build packs actually also help a lot with like optimizing the caching and making builds faster if you have done it already. So you don't need to do the same things over and over again. And I think that's also like very great. And of course, it helps you like with the versioning and traceability. And there are even like some additions you can easily add like regarding observability and metrics and so on, just by like enabling some flags to enable these features. Great. So that was basically like my talk. I hope I could show you that you do not need Docker files at all, and it's maybe better to like not do it anymore, because I believe we should make sure that me in the future, of course, but also my colleagues, we should actually like reduce our cognitive load with all these unnecessary things, like learning all the Git commands, like writing Docker files, knowing like everything about everything, you know, because we should deliver value. And this is just like one way in that direction, so we don't need to care of like what is needed to create the perfect OCI compatible container. I haven't shown it yet, but it's actually also possible. If your application consists of a JavaScript frontend and a Spring Boot backend, for example, you can have build packs actually like to build both of them at the same time in the same run. So you can have composable build packs, and that's actually also very great, right? And in the end, it makes it so much easier if all the teams in your company are using the same approach, because it's standardized, you know exactly what you're doing. If you have vulnerabilities, you know like how to fix it and where to fix it, and that makes life so much easier for everyone. And if you're like more on the infrastructure side, and you need to basically like exchange like the base operating system of a container, it's one command you can add maybe to your pipeline, just exchange it. Or even if you do it manually, it does not hurt. It's just like a 1-minute task maximum, and then you just push like the new version to the container registry and deploy it in the cloud. Great. I'm done with my presentation, and let's see if we have on Slido some questions I can answer. Whoa, Thank you very much for that many questions, but I think we can pick one or two, and then afterwards I will be also around, just like approach me and we can discuss that topic. So one question is, our built infrastructure has no access to the internet. Can I configure an internal Docker registry, especially when using Spring, Maven, and so on? So actually, like the Buildpacks by default download like artifacts like the JDK directly from the internet. But via parameters, you could say like there is a registry where you, for example, can download the tar GZ file for your Java distribution. You can point to another Docker registry, of course, because you can specify a proxy and so on. So that's definitely possible. And sometimes it's even advisable if you want to have a closer look what you actually get in the container. I mean, there are certain companies out there, and especially the security guys, they do not trust anyone in the internet. So they might want to check a little bit more, and these possibilities are out there just by providing like parameters to that. The chip plugin provides the same features as Buildpacks. So chip is just another tool to create like the images. It's not exactly the same, but the goal in the end is the same, like to create an OCI compatible container. Great. So for the other questions, I will take them later. If you have feedback, please use the tool. I would love to get some feedback as well. And then I would say like, thank you very much.